Good day everyone. So today our subject is quantitative research and our topic is all about uncertainty and probability in statistics. So uncertainty. What is uncertainty? In real world, uncertainty is sometimes called error or bias. It is a part of our everyday life, but in statistics, we try to quantitate just how much uncertainty is in our experiment, survey, or test results. So, there are two types of uncertainty. First is epistemic and second is aleatoric. Epistemic is a things we don't know because it is lack of data experience, while aleatoric is a things that are simply unknown, like what numbers a die will show in the next rule. Then, measuring uncertainty. People can quantity uncertainty their notion of probability or chance. Sources of uncertainty. Interpolation error happen because lack of data and may be compounded by the choice of interpolation method. Then model bias. Any model can be an approximation or a best guess at what true distribution might look like. Numerical error, a human error that creep in when translating mathematical model into a computer. Then observational error, due to variability of measurements in an experiment. Parameter uncertainty happen because we don't know the exact or best values in population. We can only take a good guess with sampling. Then random process matching type example. So here is the example inside the boxes. So letter A, the outcome is certain. Letter B, the outcome is possible. Letter C, the outcome has an event chances of occurring. Letter D, the outcome has a strong but not certain chance occurring. So, in other box, number 1, a couple having a female child. Number 2, getting ahead in the next toss of a 2-head coin. Number 3, getting a sum of 8 or more after pulling 4 cards in a deck. Number 4, getting a 7 when you roll a dice. Now, let's match this box. So letter E is matched with number 2. The outcome is certain, which is getting ahead in the next toss of a 2-head coin. Because when we toss a coin, it is either the result is head or tail. Number 2, the outcome is possible. Match with number 4, getting a 7 when you roll a dice. Yes, because it is possible because the dice has only a 6 side. Letter C, the outcome has an event chances of occurring. So this match to number 1. A couple having a female child, yes. Then letter D, the outcome is a strong but not a certain chance occurring, is matched with number 3, getting a sum of 8 or more after pulling 4 cards in a deck. Number 7, next is probability and statistics. Probability in statistics are related field in mathematics, sometimes combined for academic purposes. What is probability? Probability deals with predicting the likelihood of future events. Probability is primarily a theoretical branch of mathematics which studies the consequence of mathematical definition. This refers to a chance of possibilities. Probability means possibility. It is a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to 1. Probability has been introduced in math to predict how likely events are to happen. So for example, when we toss a coin, either we get head or tail, only if two possible outcomes are possible. If we toss one coin, so only two possible outcomes, it's either head or tail. But if we toss two coins in air, there could be three possible of events to occur, such as both the coins show heads or both shows tails, or one shows head and one tail. So it's either, if we toss two coins together, it's either head head or head tail or tail tail. Next is types of probability. So there are three major types of probability. First is theoretical probability, which is mga haka-haka, then not proven. Experimental probability is only experiment, not sure. Then assumatic probability. So theoretical probability, it is based on the possible chances of something to happen. The theoretical probability is mainly based on the reasoning behind probability. For example, if a coin is tossed, the theoretical probability of getting a head will be 1/2. Yes, because the other half is it's either a tail. Then experimental probability, it is based on the basis of observation of an experiment. The experimental probability can be calculated based on the number of possible outcomes by the total number of trials. For example, if a coin is tossed 10 times and head is recorded 6 times, then the experimental probability for heads is 6/10, because there is a 6 probability. Then we're going to divide it by 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. That's why the answer is 3/5. Then axiomatic probability. In axiomatic probability, a set of rules or axioms are set which applies to all types. Next is conditional probability. It's the likelihood of an event or outcomes occurring based on the occurrence of a previous event or outcomes. Then probability terms and definition. Some of the important probability terms are discussed here. So, term, sample space. The definition is sample space is the set of all possible outcomes to occur in any trial. Example of this is tossing a coin. Sample space is equal to head or tail. So, ang kuanan niya, the possible outcomes, it's either head or tail. The next is rolling a die. Sample space is 1, 2, 3, 4, 5, 6. There is only 6 possible outcomes because the dice has only a 6 side. Sample point. It is one of the possible result in a deck of cards. Then example, 4 of hearts is a sample point. The other is the queen of clubs is a sample point. Experiment or trial, a series of action where the outcomes are always uncertain, not sure. Then the tossing of a coin, selecting a card from a deck of cards, throwing a dice. That is an example of experimental or trial. It is a single outcome of an experiment. Getting ahead while tossing a coin is an event. Outcomes possible result of a trial experiment. Tail is a possible outcome when a coin is tossed. Complementary event, the non-happening event. The complementary of an event A is the event not A or not A. Standard 52 card deck is equal A is equal to draw a heart, then not A is equal to don't draw a heart. Is impossible event, the event cannot be happen. The event cannot be happen. That's all. Thank you.